Hi, I'm your mathematics tutor Mindy from Apex Tutoring. In these videos, I'm working through the 2019 HSC Mathematics Standard 2 exam. In the last video, we just finished with the multiple choice section, which ended on question 15. In this video, we'll pick up from question 16 and we'll work through question 23. Remember, there will be timestamps for the beginning of each question in case you want to jump ahead. Let's get started. Okay, question 16 says, a bowl is in the shape of a hemisphere with a diameter of 16 centimeters. What is the volume of the bowl? Correct to the nearest cubic centimeter. So we're looking at finding the volume of a hemisphere, which is just half of a sphere. The formula for the volume of a sphere is on the reference sheet. So let's take a look. The formula we want is this one here. V equals 4/3 pi r cubed. For this formula, we'll need r, which is the radius. So don't forget that when we have the distance across the width of a circle, that's called the diameter. The radius is from the center going to the outside, which will be half of the diameter. So if the diameter is 16, the radius is half of that, which is 8. Now, when we use this formula, we will get the volume of a whole sphere. We want a hemisphere, which again is half of a sphere. So we'll find this volume of a sphere with a radius of 8, and then we'll just need to take half. So we put 8 where r is, so we're going to do 4/3 pi times 8 to the power of 3. Okay, on the calculator, 4/3. We'll have to put the times in, of course, pi, and then we'll put that times 8 to the power of 3. So that's 2,144.66 ... cubic centimeters. Now let's not forget to divide that by 2 since we have a hemisphere, not an entire sphere, so I will just divide that by 2. And we get 1072.33 ... cubic centimeters. And the question asks to give the answer to the nearest cubic centimeter, which means here the nearest whole number. So if we're going to round this, and it's 1072.3, we'll round that down to 1072 cubic centimeters. Let's go on to question 17. Okay, question 17 says, the diagram shows a triangle with side lengths of x centimeters, 11 centimeters, and 13 centimeters, and an angle of 80 degrees. Use the cosine rule to calculate the value of x correct to two significant figures. So they're telling us to use the cosine rule, so we'll go and grab that off of the reference sheet. So the trigonometry section here of the reference sheet includes the cosine rule. There's two versions here. This first one, which has c squared by itself, is great for finding a side. The other version, which has cosine c all by itself, is great for finding an angle. Now we're trying to find a side, so we're going to use the one that is c squared equals. So the formula is c squared equals a squared plus b squared minus 2ab cosine c. The setup is important when using the cosine rule as well as the sine rule. When we're finding the side c squared, that's what's going to be opposite of the angle big letter C. So if this is what we're going to use for little c, because that's what we're trying to find, is the x, then the angle we want to use in cosine is the 80 degrees across from it. A and B are then the other two sides. It doesn't matter which one's A and B, as long as C is chosen so that that's the side that you're finding. So we're going to put these into the formula. And let's put it in the calculator. And we get 240.3366, etc. Now remember, though, that this is what c squared equals to. And similarly to how we do with Pythagoras' theorem, we need to square root this to get what c is equal to. So I'm going to hit square root, answer, equals, and we'll get about 15.5. Now, careful, because the question does say two significant figures. With significant figures, we start from the first non-zero digit, count, in this case, 2 digits, and round to that place value. So we start with the 1, and then the second one is that first 5. So we're just rounding here to the whole, to the ones place. And since it's 15.5, that will round to 16 centimeters. And that's our answer. Okay, let's go to question 18. Question 18 says, Andrew, Brandon, and Cosmo are the first 3 batters in the school cricket team. In a recent match, Andrew scored 30 runs, Brandon scored 25 runs, and Cosmo scored 40 runs. Part A of this question says, what is the ratio of Andrew's to Brandon's to Cosmo's runs scored in simplest form? So we're going to put these into a ratio, starting with Andrew, which is 30. Then Brandon, which is 25. Then Cosmo, which is 40. And now we just need to simplify that ratio. To simplify a ratio, we need to be able to divide all of the parts by the same thing. 30, 25, and 40 are all divisible by 5. So if we do that and divide each of these by 5, we'll get our simplified ratio. 30 divided by 5 is 6. 25 divided by 5 is 5. 40 divided by 5 is 8. And we should double check if it's possible to simplify any further, but 6, 5, and 8 don't have any common divisors other than 1. So there's no further simplifying to do. So that's our answer, 6 to 5 to 8. Now, part B of this question says, in this match, the ratio of the total number of runs scored by Andrew, Brandon, and Cosmo to the total number of runs scored by the whole team is 19 to 36. How many runs were scored by the whole team? So what this question is saying is that when we combine Andrew, Brandon, and Cosmo together, all of their runs, and then put that into a ratio versus the runs scored by the entire team, that ratio is 19 to 36. Now, we know that altogether, Andrew, Brandon, and Cosmo scored 30, 25, and 40 runs. So if we put all that together, we can add it up. which means they scored a total of 95. And we're curious then, how many runs were scored by the whole team? So this is an equivalent ratio where we're given the simplified version and we're trying to basically unsimplify it. So we want to know, what would we times 19 by to get 95? And we can work that out by checking 95 divided by 19, and we can see that it would be multiplied by 5. So we can multiply both sides of this ratio by 5 to create our equivalent ratio, the left being 95, of course, and the right side is 36 times 5, which is 180. So the runs scored by the whole team is 180. And that's our answer. All right, let's go on to question 19. Okay, question 19 says, the heights in centimeters of 10 players on a basketball team are shown. We have a list of numbers, and then it says, is the height of the shortest player on the team considered an outlier? Justify your answer with calculations. So we need to work out if we have an outlier on the low end of these scores. To do that, we can use the formula that is on the reference sheet. So let's take a look. The formula we're looking for is part of this here. The lower outlier is going to be less than Q1 minus 1.5 times the IQR. Which means we need to know what is Q1 and what is the IQR, which is the interquartile range. To get the quartiles and the IQR, we're going to split this data in half and then split each half in half again. So let's find where the middle of this data lies, which is the median. So let's count how many scores we have here. There's 10. If we split that in half, we'll have 5 scores on the left and 5 scores on the right, which would occur right here. So the median is between 192 and 193. We don't need to know what that median is, but it would be 192.5 if we needed it. What we want to do now, though, is to get the Q1 and IQR by splitting each half into half again. So the first 5 scores, when we split that in half, the middle score there is 185, and in the upper half, the middle score is 194. That is Q1 and Q3, respectively. The IQR is Q3, quartile 3, minus Q1, quartile 1. So it's going to be 194 minus 185. Which is 9. Now, any outlier is going to be below, as we said, Q1 minus 1.5 times the IQR. So it will be below Q1, which is 185, minus 1.5 times 9, the IQR. And we get 171.5. So if we do have any scores that are smaller than 171.5, that would be considered an outlier. And the score, 170, is smaller than that. So yes, 170 is an outlier because it is less than 171.5. And we're ready to go on to question 20. Okay, question 20 says, a roulette wheel has the numbers 0, 1, ... all the way up to 36, where each of the 37 numbers is equally likely to be spun. If the wheel is spun 18,500 times, calculate the expected frequency of spinning the number 8. So to get the expected frequency, we want to know what's the probability of getting the number 8, and then we can just multiply that by how many times we would spin the wheel. So the number 8 is just one out of the 37 numbers. So it has a probability of 1 out of 37. So that means that 1/37th of the 18,500 times we expect to get 8. So we will times that by 18,500 to get our answer. And our answer is 500. Let's go to question 21. Okay, question 21 says, a person owns 1,526 shares with a market value of $8.75 per share. The total dividend received for these shares is $1,068.20. Calculate the percentage dividend yield. So the percentage dividend yield is what we get when we take the dividend per share divided by the market value per share as a percentage, or total dividend divided by total market value of the shares as a percentage. I'll take the route where we'll take the dividend for each share divided by the market value for each share. So if there is a dividend of $1,068.20, that's for all 1,526 shares. I'll divide that by 1,526 to get the dividend per share. And so we get 0.7. We're talking about money, so that's 70 cents. Now the dividend yield, again, will be the dividend per share as a percentage of, so divided by the market value of each share. So we get 0.08. Now I have not converted this to a percentage yet. You may already know what that is as a percentage, or you can times it by 100 to convert it, and that's 8%. And that's our answer. Okay, we're ready for question 22. Okay, question 22 says, two right-angled triangles, ABC and ADC, are shown. Calculate the size of angle theta, correct to the nearest minute. Okay, so this is a two-triangle problem. We often need to work out some information in one of the triangles in order to be able to work out the final piece that we're looking for in the other triangle. So if we do look at our ultimate goal, which is theta, we have that triangle there, and there's just not enough information to find theta because we only have one side to work with. So if we look at the other triangle below it, we have two sides, and we should be able to use those to find the third side. And that third side is part of the triangle above it, which will then allow us to find theta. So first, let's find the side I labeled x, which is the hypotenuse of the triangle on the bottom. To find that side, we can use Pythagoras' theorem since it's a right triangle and we have two sides and we just want the third side. You'll need to remember that Pythagoras' theorem is c squared equals a squared plus b squared, because that formula is not on the reference sheet. Now I call the hypotenuse, which is normally c, x, so I can put that in where c is, and then the 2.5 and the 6 can be a and b, and it doesn't really matter which one's a or b, as long as c is the hypotenuse. We get that x squared is 42.25. Don't forget that we now need to square root that to get what x actually is. So I will square root the answer, and we get 6.5. So this side that I called x is 6.5 centimeters. And now we can look at the upper triangle and see that its hypotenuse is 6.5. We can use that along with the 4.9 to get the size of the angle theta. This time, we're going to be using trigonometry to find an angle. So I would start by labeling what sides I have. 4.9 is the adjacent, while again the 6.5 is the hypotenuse. So I'll use adjacent and hypotenuse, which is cosine. If you don't have those memorized, you can use SOHCAHTOA to help you remember, or you can take a look on the reference sheet to see that cosine is adjacent over hypotenuse. So we'll write cosine of the angle, which is theta, is equal to the adjacent, which is 4.9, over the hypotenuse, which is 6.5. Now, to get our angle theta, we will take inverse cosine, which is cosine with a little minus 1 of 4.9 over 6.5, which we'll do on the calculator by hitting Shift cosine, and we'll put the 4.9 over 6.5. And we'll get 41 degrees, 41.07 ... But don't forget that the question's asking us to put it to the nearest minute. So we'll hit the degrees, minutes, and seconds button on the calculator, which looks like a little circle and then an apostrophe and a double apostrophe. If you hit that button, it'll convert it to show us that that would be 41 degrees, 4 minutes, and 31 seconds. Now, if the seconds is 30 or higher, which means halfway or more to the next minute, we round the minute up. So the 4 minutes, 31 seconds rounds up to 5 minutes. So 41 degrees in 5 minutes is our answer. Okay, let's go to question 23. Okay, question 23 says, a set of bivariate data is collected by measuring the height and arm span of 7 children. The graph shows a scatter plot of these measurements. Part A then says, calculate Pearson's correlation coefficient for the data correct to 2 decimal places. So this is purely a calculator question. So you need to know how to calculate Pearson's correlation coefficient on your calculator. I'll show you how to do it on the Casio FX82AU+2. So the first thing we have to do is go to stats mode. We need to go to bivariate stats mode. So you hit mode and then choose stat number 2. And bivariate stats mode is number 2, where it says A plus BX. So when we hit 2, we'll get the 2-column frequency table. If you don't have the frequency column, that third one on the right, it's okay. You don't really usually need that, but if it's there, it'll just automatically fill in with 1, so you can ignore it. Now we need to enter each of the data points that we see on the scatter plot. Now the data is going to come from the scatter plot. We need to realize that each point, which is a coordinate of x and y, also represents the data pair x and y, x being arm span and y being height. So this first coordinate here on the left, the point 136, 142, is a data point of someone who has an arm span of 136 centimeters and a height of 142 centimeters. So that's our first data pair. We're going to put 136 in for x. When we hit equals, our selector will go down. We then scroll to the right and up with the arrows so we can put the y data point of 142 that goes with the 136. Hit equals, and now we're down again, and I'll scroll left so that we can enter the next data point. The next data point is 138, 142. So I'll type in 138 equals, go right and then up, and then 142 equals. And then I'll go left on line 3, ready for the next data point. And that is 140, 146. So I'll type that in. Then the next one is 144, 148. And then the next one is 144, and it's between 148 and 150. That's 149 then. Next is 146, 150. And lastly is 148, 152. Okay, now that the data is all in the calculator, the next thing we need to do is exit the data table by hitting the AC button. And now, to get Pearson's correlation coefficient, we'll get into the stats menu by pressing Shift, number 1, and the thing we're looking for is in number 5, REG, which is short for regression. So if I press number 5, Pearson's correlation coefficient is the letter R. So I hit 3, I see R up there, and when I hit equals, it'll tell me R is 0.98111, etc. Now, they want this to 2 decimal places. So 0.981 will round down to 0.98. And that's our answer. That's Pearson's correlation coefficient. Okay, part B says identify the direction and the strength of the linear association between height and arm span. So this is about the trend in the data, whether it's going up has a positive gradient or going down with a negative gradient. And it's also about its strength, how closely or tightly these data points follow a line. So we can see that in general, these data points are going up and quite closely follow the line. Pearson's correlation coefficient is a numerical measure of how tightly those data points follow that line. 0.98 is quite high. So it's definitely a strong relationship, and as we said, it's going up, so it's got a positive relationship as well. So we need to say that it is strong and positive. Now part C says, the equation of the least squares regression line is shown. A child has an arm span of 143 centimeters. Calculate the predicted height for this child using the equation of the least squares regression line. So the least squares regression line is related to the line that I drew, which we might call the line of best fit, but it's been mathematically generated to be the best fitting line for that data. So we're going to just use the equation they're giving us, not the one that we might have drawn. And we're going to predict the height for a child with an arm span of 143 centimeters. Arm span goes in this spot in the formula, so we just need to plug it in there. So height is 0.866 times 143 plus 23.7. And we get a prediction of 147.538 centimeters. And that's our answer. So we'll take a break and stop there for this video, and we'll pick up with question 24 in the next one.